Hello, so this video I'll show you how you can start programming drones using ROS Development Studio. It's provided by the Construct Sim. If you are new to RDS, ROS Development Studio, you can just access rds.theconstructsim.com and just do a sign up, and you'll be able to see this screen with a lot of public simulations that you can just run and start programming. So for this video I will choose the drone simulation. I just need to keep the main.launch file selected and press the run button. Okay, we need to wait just a few seconds while the simulation is being loaded. As you can see, we have here on the left side a Jupyter notebook with some instructions about the simulation, about the robot that we're going to use, some Python code that you can use as a template or even execute. We have here on the center the simulation, which is ready. On the right side you have an IDE. You can explore the files, change, and through the terminal here on the bottom right side you can compile everything that you are used to do in a regular terminal. Okay, so first of all let's follow some instructions of the notebook. And we have here Parrot drone simulation. We have the drone here on the middle of the screen. Let's take a look what the simulation provides for us. Just execute a ROS topic list here in the terminal, and you can see we have a lot of topics coming from the robot. I will start from the beginning. Let's see the command vel topic. For example, you can send velocity or position values to this topic. The drone has two cameras, down camera and front camera, that you can use for perception algorithms or just for monitoring the flight. We have values about the acceleration, position, and velocity, which comes from the odometry algorithm, which is running inside the drone. The IMU. We have a topic just to send a land command to the drone, another one to perform a takeoff. We have a topic called position control, which is used to assign to the drone position control mode, fly mode. We have another topic here that provides the sonar data. Velocity mode, to switch to the velocity mode, velocity flying mode, and other topics that comes from Gazebo, standard topics, and standard topics from ROS. Okay, so let's start moving the robot. So here at the beginning of the notebook you can see there are some instructions that you can execute in your terminal. So let's try this one, for example, which is basically publishing an empty message to this topic here, drone takeoff, and publishing just once. Okay, so let's try to do it. You can just select the text here and copy, Ctrl+C, paste here to the terminal, paste, just press enter, and okay, we have just published an empty message to this topic, drone takeoff, and now the drone is flying. Great, you can do the same, publishing an empty message, but now for the drone land topic, just once, and you will see the drone landing. So let's try to do it. Just paste the command, press enter, and okay, now the drone is on the ground again. Great, so let's try to do something more interesting. Let's start coding. You can use the notebook as you wish. You can create new code here, new code cells, like hi, say hi, and I will create here some some nodes. Let's put the test type cell. Let's start code in ROS for drones. Okay, so let's try to do the same we did using the terminal, but now using Python. So let's start importing the ROS.py library because we want to program in ROS, in Python for ROS. So we can just create a cell, import ROS.py, and the first thing we need to do is to initialize a node because we can do anything without a node. So let's call it drone. We'll call it my drone node. Okay, it's done, and you can just execute the cell, pressing Ctrl Enter, or just clicking here on this button, run cell. And now you can check here in the terminal that we have a new node called my drone node. Great. So let's create a new cell, and now I will create a publisher to this top key here, drone takeoff. So let's start doing creating an object. I will call it pub takeoff, which comes from ROS.py publisher to the top drone takeoff. I want to send an empty message, so I need to import the empty class from standard messages, and I need to set also the queue size. For this example, equals to is enough. Okay, and you can just click here and execute the cell, and it's done. Now we have a variable pub takeoff ready to be used. So I don't need to import again the empty type, the next cell. So I can just create a variable called var empty, which is equal to empty, and just use the takeoff publisher to publish this message var empty. And the drone is flying. Yeah, okay, so very simple. Let's try to do something more, something different. Okay, so we can check here. We have a top key to set the position control, flying mode. So let's take a look on this position control. I want to see how to use it, so let's stop key info to see what kind is this message. So stop key info, drone position control. Okay, it's a golden message. So using the position control fly mode, let's create a cell here. Let's import the bool type from standard messages, and let's create variable equals to bool. And we want to publish to this top key here, drone position control. So pub post control, we call it. It's a publisher that publishes to the drone position control messages of the bool type, and again the queue size equals to 1. Okay, let's execute this cell, and now we have a publisher to this top key, drone position control. let's say variable dot data equals to true, because I want to use the position control, and let's publish this value using our publisher object. Publish variable. And just to check that our message arrives to the topic, let's use ROS topic echo drone pulse control. Let's keep it waiting for the messages. Okay, nothing is coming because we didn't publish yet. So let's execute the cell. Great, we have received the message here, data equals to true, and the drone has just landed because we have switched the flying mode, so it's not flying anymore and it's waiting for the position values. Great, so let's create another cell here. I will describe what I'm going to do, which is sending position messages. Let's create another code cell, and let's take a look on the message on the topic that we want to use. Stop the list, and we need to publish to the command val topic. So ROS topic info command val. This is a twist message, so we need to import from geometry messages the twist class. Let's create a variable for twist. How you call it? You can call it whatever you want. And also a publisher. I will call it pub position, which is a publisher that is going to publish to cmdval messages of the twist type, and kill size equals to 1. Okay, so let's execute the cell, and we have this variable here, var twist, and the publisher pub position. Let's create another cell. Let's fill the twist message. If you don't remember how to fill it, you can just type here ROS message show geometry messages twist. Okay, so the twist message has linear and angular parts. In this example, we're going to use this linear property. So for twist linear, x, y, and z. I want just to perform a takeoff. I will change the x and y values, for instance. So let's try to take off. And finally, for public position, dot publish, var twist. Okay, so let's try to execute the cell. Let's see if it works. Great. So as you can see, the drone is flying, and you can play with the values here. Execute the cell again, and the drone will obey and go to the points that you are setting here. Okay, so that's how you can start programming drones. So as you can see, it's very simple to use this simulation here. And of course, you can try to do some more challenging stuff, like trying to avoid the obstacles, like this wall here, or this other wood obstacle here, and maybe using the cameras to avoid the obstacles, or using the down camera to achieve some points, like if you want to fly over the wall and just follow the wall line here, or stuff like that. Well, I hope you have enjoyed this video. If you have some doubt, please leave a comment or talk to us through the email. See you.